So I'm happy to introduce Nadja and Jean-Christophe. Nadja is from the Stuttgart Academy of Fine Arts. Jean-Christophe, Managing Director at NOAA. And they have quite an interesting presentation regarding the research of Azimuth Adjustments. And they might raise the questions that we all need to re-digitize our entire collection. So very interesting.
Thank you very much for introduction. So, Christophe,
okay.
Start.
Hello, everybody. Happy to be here. It's my second time actually in the Royal Irish Academy. I was there in 2017, I think. Yes, 17, right? Archives at Risk. Yeah, I'm presenting this together with Nadja on behalf of my colleagues Christoph Gerstbauer and Peter Kummer, who did the major work actually together with Nadja on this. I do allow myself to tell you a little bit, a few slides. I promise it's not too much marketing, but a little bit about NOAA. We are manufacturers of specialized archiving software and digitization tools. Around more than 6.5 million hours of material worldwide have been transferred with our solutions. Our biggest impact nowadays is more like also taught to organize the logistics. About 10,000 carriers are moved per day in about 30 digitization factories worldwide. Everything is built upon file and signal quality gate. The company is based in Austria, and the engineering is done in Germany. So I would say German engineering with an Austrian heart. Our mission is to help humanity preserve and enjoy culture for eternity plus one day. Okay, just to give you an idea, these are some of these preservation factories. For example, here we are talking about one in Abu Dhabi, which does not as much as Bob, but it does actually 10,000 carriers per month. The limitation comes from an obvious theory of constraints limitation that you should size a system based upon the weakest point. And the weakest point was that there were only 40 catalogers there to be able to validate the content which is going inside the MUM system. Talking about Abu Dhabi, and this will be a very good link to Nadja then, we will talk today about one specific feature of, we have about 52 software programs, products, and we will just talk about one specific feature from one of these 52 products, which we recently developed because of an incident with Nadja, which I will just tell right now after that one, and it's called the Azimuth Stereo Guide. That has been motivated by all of these audio systems which we have worldwide in Hungary, in Mexico, in Sweden, whatever you call them. Recently, Nadja was for us in Kuwait Radio doing a nice training. But before that, she was in Abu Dhabi. And Nadja and myself, we know each other for more than 30 years now. And she called me from Abu Dhabi and said, Christoph, your Azimuth monitoring tool is not as good as I would expect to be it. And I said, what's going on? And then we realized that there were cassette copies, secondary migrations on tapes, misaligned tape machines, and so on and so on. But there was a big discussion going on. And she said, well, we have to do something else. And from here, I pass over to Nadja.
Yeah, as a revenge, I had to take the test, which I will outline in a very few minutes. But first of all, I would like to come back to the topic we had today already several times, and this is triage. Decommissioning. My question is, what do we leave back on the original signal? What do we leave back on the original tape? So with every single digitization we are doing, with every single standard transfer, we're leaving behind technical information which we simply do not capture, like, for example, the high-frequency bias signal. The high-frequency bias signal could be the perfect reference for the digital restoration of speed fluctuations if we would read it out. Yeah? And the second thing I would like to focus on is the azimuth, azimuth deviations. So can we really say that we did our best when we start triage and decommissioning and throwing away our originals. Old recordings sound dull. Yeah, this is quite common. I had the chance to digitize some of the oldest collections worldwide, stemming from 1936, the year where the magnetic tape recording in Germany was developed, until 1942, and none of the tapes sounded dull, provided that you replayed it on a perfectly aligned machine with new heads perfectly cleaned and controlled the azimuth for every single tape. So, by definition, the azimuth, what does it mean? By definition, the tape should travel exactly 90 degrees towards the magnetic head gap. Yeah, so a perfect 90-degree angle is what we would like to have. In practice, this does not happen all the time. Honestly, it does not even happen between two different alignment tapes, which should be perfectly aligned. So if you compare them very carefully, you see a difference in azimuth, even if it's very minimal. So why does azimuth deviation happen? For example, you have a portable machine where your reporters went around, they dropped it 5 times, they did not align it, things like that happen in practice. So you can assume that every single tape has a certain azimuth error. What does the azimuth error mean in practice? The azimuth error means that you do not read out a deviation from the recorded angle, means that you do not read out high frequencies in the amount you could do. So, for example, the sound then would be like that. Yeah? If you have a 10 kilohertz phase deviation at 10 kilohertz, for example, your signal is nulled out. You don't have a retrieval of this information. So, in practice, this means that you should align for every single tape. Even if you have a very good management of service of your machines, you should nevertheless realign on playback your azimuth. How is this done? This is usually done with a screwdriver on the magic screw where every technician told you, every service technician told you, don't touch this screw. Yeah? Now we have to touch this screw for every single tape because we have to bring the angle of the head, which is mounted on a movable plate, to the same deviation as it is recorded on the tape. You can see it here in the outline. So if you have a mono full track tape, which you are reading out with a mono full track head, then the options how to control this are very low. So usually you need to use your ears or maybe a spectral tool. But in a mass transfer, you usually use a stereo heads or butterfly heads, and then you have the chance with a mono signal, with a mono full track signal, to measure the phase deviation between the two channels. Yeah? With a stereo signal, as you see on the third upper you see that you have two non-related signals. Well, they are stereo and in one direction, but they are not exactly the same because there is the spatial distribution. So how to align such a signal really in a perfect way? So we were thinking of optimizing this. Sorry, there is one video I wanted to show you, and this shows the effect of azimuth misalignment. What we did in this, wait a second. What we did in this video is we took a recording of white noise, and we were aligning the azimuth or misaligning and then realigning the azimuth screw. And what you see is exactly the comb filter effect whenever the head curve, the head response curve shows the signal. I show you this video. So you see the machine and the two azimuth knobs, the tape is passing by, and the tape is recorded with noise. And you see the spectrum is very low. You don't have high frequency response, but if you align the azimuth to the perfect value, your high frequencies rise, and they rise up to the maximum, which should be the full spectrum. Yeah? Here you see it, what happens if you turn this screw left to right. And the effect is like, yeah, sorry for what this is. Okay, so how could you now design a tool which optimizes this treatment in a mass transfer? Yeah, you have to be quick. You have tons of material waiting, sitting on the shelves. You have to do it in a very good way. So what we do is we compared different methods how we could do this. For example, the method one is to mix the signal to mono and adjust for the highest frequency response. The second method is to mix to mono, but to adjust for the lowest high frequency response, but with a phase reversal. Yeah? Phase reversed, mix to mono, and then adjust for the lowest response. Then the third one is the original mix with goniometer support. So you look at the goniometer on the stereo signal and try to align best possibly. And then certainly measurement number 4 is the Azimuth guide tool that was developed. This was used as a control for this test. And then you certainly have a phase torch tool or correlation meters, but these two methods were not evaluated in the test setup we designed. Is this correct? Yes. So we prepared a tape which had several signals on it. First of all, 30 seconds of pause, then the content with a certain deviation angle, and then 10 kilohertz, 30 seconds of 10 kilohertz sine tone as a reference. We chose to use the 10 kilohertz sine tone as a reference because this is, first of all, the one where you're aligning the azimuth on your alignment tape, but it's also very easy to calculate phase deviation. For example, if you have a 36 degrees deviation at 10 kilohertz, you are about half dB wrong. Yeah? The setup was pop music, stereo, then mono speech, and classic music in stereo. And I proceed. The playback setup was as follows. The tape machine with the alignment screw. Then the signal went into the AD converter of the NOAA N7000C audio interface, and then was mixed to mono and phase inverted on a preamplifier, and then the three different signals were provided, and the test persons had to listen with the headphones. And in parallel, the phase measuring, the phase difference was measured at the angle of 10 kilohertz with the Azimuth guide tool, and this was used for check back in the very end and for the analysis of the results. So we had invited 4 professionals and 4 non-professionals. Here you can see the age and the around somehow verified listening ability. So some people are limited in their high frequency response. So as I am, my restorations sound better every year because I don't hear the noise anymore. That's the reason why I need a tool. Okay, and we also measured the adjustment time and the azimuth difference angle in values. Yeah? And so you see in the upper in the upper line, you see.
Oh, sorry.
Oops, sorry. You see always the time, and so for example, with the first run, the time used for aligning the azimuth and the deviation, that was the result. So if we go to the, all in all, we had 256 measuring points so that we could have a very nice statistical number of tests. So how did this work? The tape was played back on the tape machine. And then, for example, in this setup, there was only the phase correlation meter. The goniometer was available for the test person. but it was controlled with the Azimuth guide tool. So, but I, as a test person, did not see the Azimuth guide tool at that time. So I had to do it with the headphones just by myself. And yeah, everything around 36, 40 degree, you can say it's okay, it's neglectable if you look at 10 kilohertz, because at 10 kilohertz, this is half a dB of loss. Nevertheless, here you see how this worked. And in the end, I was allowed to use the Azimuth guide tool, and all the test persons were allowed to use this tool. And what you can see is that the alignment worked perfectly, and the 10 kilohertz tone at the end of the recording showed that this azimuth was very well aligned. So we have a very few, this is only the fluctuation of the tape in front of the head, what you can see. So this system worked really very well. And yeah, and here is the statistics of the overall time the persons used to align the azimuth with the different methods. So with the first mono mix, all groups, you can say, were about 43 seconds for aligning the azimuth, which is quite some time. Yeah, you use it. Method the inverted mono mix gave the best results. The goniometer control was also very time-consuming, especially with the non-professionals. And with the azimuth guide, all in all, we could then really significantly reduce the time for alignment, but also rise the quality significantly. And this is the point where I hand over to Christophe again.
Especially Nadja, when she did M4, she took longer because she wanted to get the absolute optimum out of it. So what does that mean in statistics? Because we want to have evidence-based analysis and not marketing messages. And I can't hardly see this here. I will just change it a bit. Yes, because this will fall. This is not good. I will look here. So again, we have three measuring methods. You see here three measuring methods. The fourth one will come on the next slide. Each of these measuring methods had 64 measuring points. Okay, so we had 8 probands, so 64 measuring points. Method 1, the one where he listened to the highest frequencies, yielded out that we had around 50% quite within the corridor, and 50% where I have to look to my mobile phone because I've put it on here. Yes, 34 were okay, 21 were not okay, 3 were unacceptable. So you can see 40% was wrong actually in this listen to the highest frequency. The second method, 57 were okay, 4 were not okay, 2 were completely unacceptable, so you can see 10% were wrong. So this second method, by forcing people to listen to the lowest frequency by inverting one channel, was proven to be absolutely fine, and you can use your ears for that one. The third one, the third one was the one which is, unfortunately, the one which is the mostly represented within system engineers and audio engineers. 30 were okay, 11 were not okay, 17 were completely unacceptable. You can say that 50% of the results were wrong when dealing with stereo azimuth and goniometer. And now comes that slide, which was already shown, and then we looked at the fourth method with our azimuth guide, and it was really quite interesting that all of the problems, no matter whether they were professional or non-professional, could hit the target corridor by actually 100%. Very interesting. Do you see these 2.2 points? This was the best mastering engineer of Austria, who insisted, although he saw that he could just measure it towards 0 degree, he insisted to deviate it a little bit, and he said to me, no, I need to do this. It sounds more dramatic. So one can see how much interpretation is when you deal with transfers, how much interpretation, personal interpretation comes into the game, how much fatigue comes into the game. Most of these other points were just only used to use your ears, and they were there, so each program was there for 2.5 hours. And there are really, and at the end we did the azimuth guide tool. So it was really interesting to see all of them looking at the results and were just completely shocked about the wrong way they did it, although they were thinking that they were doing it correctly. I think there is an automatic move on. Okay, so when you look at the results, consistency across the listener groups, professionals versus amateurs, you couldn't really see a big difference actually, because looking at high frequencies, we in these factories, typically ingest operators are handling mostly broadcast material, which are quite uniform, so they can be trained within a week to do that correctly. There is an automatic one. And so here we can see that the difference between the different methodologies do not really impact by any means the results. So, conclusions. So I hope that is one. So the best manual method, as you have seen from before, was really M2 by just listening to the lowest frequency. So if you don't have any tool at your hands, then you can only trust your ears when you invert one signal and press mono. The best measurement tool supported method was proven to be statistically proven and evidence-based proven M4, which is this new Azimuth guide tool, which was developed by 3 engineers in my company after Nadja gave us this shot from Abu Dhabi, and they took them actually 5 months to do this. So I think it's really a very nice result what we can see here. The method with the highest potential to make azimuth worse was unfortunately the one which is most commonly used. Even 75% of the professional test candidates performed better with M2 than with the preferred method M3, so which is also quite interesting. Same spread of results from methods M1 to M3, and yes. So I have now remarks because the question was, should we do our archives again? When you look at the typical representation of sound archives in Europe, I give the example of the Austrian broadcaster ORF with about 120,000 hours of radio archive, which was digitized with our tools. 50% of it was speech and mono, and the other 50% was music and stereo. So, goniometer for mono, no problem, you can use that. For the 50% of the stereo, of course, if we presume that 30%, if presumed that 40 to 50% are wrong, that could raise a flag. So what we recommend everyone is just to make some test samples and test data, and telling what just Nadja did from the very beginning, before cassation, or before just throwing them away, just try to recover those high frequencies possibly. When you look, for example, in the Arab regions, they have, because of non-maturity of technology back in the 70s and 80s, 80 to 90% mono signals, and maybe 20% only stereo signals. Yeah. I think those who just really turned around without knowing what they do, very likely did it worse. Those who didn't do anything might be fine if it was like a broadcast recording. But in general, you can't give a real answer on that one, except that I would reconsider for your VIP content to look into a better transfer, recovering more high frequencies based upon the empiric results which we have driven within our company. Thank you.
Any questions in the room? Of course, Charles.
Hi. Thank you very much for that presentation. It's very, very interesting and really lovely to see that attention to detail. Now, if we're going to do them again, the really most important stuff, as well as the azimuth, which is one of the adjustments on the audio head, have you considered the height of the head and the zenith of the head as well for signal-to-noise ratio? And also phase distortion.
Okay, so
because it's a three-dimensional position.
Yeah, well, this is part of a normal adjustment procedure which you do typically with reference tapes. So this is not something where you could expect so much differences in the broadcast archive regarding this part. But that part is more likely to happen than this part.
Okay. So you would just be happy that there was enough latitude in the head to recover enough.
Well, your experience.
So you're not worried about signal to noise, just high frequencies.
In my world, which is a different one from the broadcast archive, which is ethnomusicological collections, field recordings, and so on. This is a daily routine to look if this is, for example, a reason why we always digitize a mono full track recording with a butterfly head, because the tilt of the head might be already bad recorded on the original. So even if we try to align this, we will always have a difference in quality between the left and the right channel.
And do we take this further and go into the video domain and make sure the azimuth of those heads are also correct?
Yeah, well, that is another level of engineering cost. Completely another level of engineering
So we have
cost.
to decide where we draw the line.
At the moment, we have capacities to do developments in-house, of course. I mean, we are a decent company. We're very happy that we can show this like this and also share these results and give evidence-based paths. But on Azimuth, on video, at the moment, we don't have
At a simpler
capacities.
level, on a lot of analog VTRs and digital ones too, we have dynamic tracking. So we have fixed heads and we have dynamic heads. And there's quite a considerable signal-to-noise ratio difference between those heads. And I don't think everybody standardizes in one way or the other for that. So I think taking your approach to audio, maybe we could make more refinements to the video side as well, even if it's just in standard practice.
Happy to go deeper in detail with you, Charles.
Yeah.
Like that. Yeah.
Where do we draw the line? Maybe that's the name of the presentation next. Thank you very much.
We draw it at the highest quality.
Thank you, Nadja. Thank you, Christophe.
Thank you very much.
Let's set up the panel. So just give us a minute, and I hand over the mic to Brecht.